Good afternoon, everyone. Today we'll be dealing with generator, sealing, and cooling system. In the generator, we call it synchronous generator or alternator. It is a doubly excited machine, which means that we are having two different sources of power flowing in the rotor and the stator. So both stator and rotor gets heated. If we can cool the stator and rotor by any means, this will increase the current carrying capacity of our system. And if the current carrying capacity of the system will increase, then we can have more output from the machine itself. So initially we had generator that would generate suppose 100 megawatt of power. So we needed to cool the generator so that the temperature due to the I square R loss. In the stator we have the current that is flowing out. It will be heavy current, so I square R loss would be less. So the temperature rise should be less. So we had air cooling system, means we just cool the system or generator through air. But as our capacity of generator increased, as the capacity of the generator increased, we had to increase or change our cooling media. This means we had to change the media used for cooling the stator and the generator. Now, every loss that takes place in the generator will finally be reflected as heat loss in the stator or heat loss in the generator. So, a typical generator will, in 210 megawatt generator, will have near about these losses. So, in order to have an effective cooling option in the generator, we can have air cooled generator, or we can have water as a cooling media, or we can have hydrogen as a cooling media, or a mix of these. So initially when the size of the generator was smaller, we could sufficiently cool the generator using air. In that case, the rotor had a fan mounted at the end itself, and as the rotor rotated, it either forced the hot air from the generator outside, or it forced the cold air from outside the generator to inside. As we increase the size of the generator, then we move to hydrogen cooling media. This means hydrogen cooled. What we did? We cooled the rotor by hydrogen. This means the generator was totally sealed so that no outside material could ingress inside, and we circulated this hydrogen inside the generator. Again, as we increase the size of the generator, we complemented this hydrogen cooling by using water as a cooling media for stator. So stator was water cooled and rotor was hydrogen cooled. This again effectively increased the cooling limit. So the generator was cooled better way. Apart from this, as we have moved forward, we have used water cooled rotors and stators also. In some countries, we are going for this. Now, in a cooling nomenclature, if we go, any equipment that is being cooled by any media, in this case is a generator, we have 4 alphabets that will be depicting it. This will be having 4 alphabets, suppose A, B, C, D, and numerical values, suppose X and Y. So we have 4 alphabets and 2 numerical values. These alphabets will denote what type of cooling media is being used. So this, if you see, this alphabet has meaning, and this numerical value has different meaning. So if we go for our that is not here in the PPT itself. The first alphabet that is there, it shows the type of generator, whether it is a hydro generator or whether it is a turbo generator. And it will designate, if it is T, it will represent a turbo generator, if it is H, it will represent a hydro generator. So the first alphabet, suppose it is so it will be T. The second alphabet designates what is the cooling media for rotor cooling. Means how are we cooling the rotor? If in our case, suppose we are using hydrogen, then it will be H, and if it is air, it will be A. Now the third alphabet designates the type of cooling, means whether the hydrogen goes in radially, whether the hydrogen is cooling it directly, or we are using indirect method of hydrogen cooling. Means we have infused the flow hydrogen, and that will indirectly cool the rotor winding. And then we have the fourth alphabet that designates the type of cooling of stator. Whether the stator is directly cooled and D, and indirectly cooled, and whether it is directly or cooled or indirectly cooled. I for indirect, D for direct, and F for cold. Let's take one example that will show you. See this four alphabet first. Here it is T. This means it is a turbo generator. Then we have H. H means this is cooled by hydrogen. Rotor is cooled by hydrogen. Then we have R. Means it is radially cooled. Means the air will, the hydrogen will enter radially into it and go out radially. The fourth alphabet is I. This means stator is indirectly cooled. So we have I, indirectly cooled stator. This indirectly cooled, what we mean that there is no direct contact between the winding and the coolant. So suppose this stator is water cooled, what we'll have? We will have water in the tube. And the stator will be cooled indirectly by the water flowing in the tube. There will be no direct contact between winding and the tube. So water in the tube. So it is this nomenclature will be depicted in all the generators that we are having, whether it is hydro or whether it is turbo generator. Now, two numerical values. First numerical value 108. This shows approximate dia of the rotor. And the second numerical value shows approximately core length of that rotor. So this will give us the size of the generator itself. So in a nomenclature of cooling, this data is very important. Other examples we can TAR like this. The turbo generator, the rotor is air cooled and it is air is entering radially into it, and the stator is indirectly cooled. Indirectly cooled, maybe by water. So these are various nomenclature of stator cooling. Now as we have moved from air cooled generator to hydrogen cooled generator. But there is a question that why we are going for hydrogen. We have more options as nitrogen, carbon dioxide, methane, helium, hydrogen. These air, if we compare, then we see that how effective is a coolant in carrying the heat from the generator to the outside and releasing the heat to the outside. So we compare it in four parameters. First is specific heat, density, thermal conductivity, heat transfer coefficient, velocity. Velocity, why we have seen? We are taking velocity so that the speed of the air, hydrogen or helium, whichever we are coolant, should be constant so that the other four properties can be compared. If you see, maximum heat carrying capacity and maximum heat conducting capacity comes out to be of hydrogen. Also, helium is close to it. But production of hydrogen at site or storing of hydrogen at site is far more easier and cheaper than producing helium. So we are going for hydrogen. Now, specific heat it is 14 times more than that of air. Density is 0.14. This is 14 times less than that of air. And thermal conductivity means how much heat it can retain is nearly 7 times. So these properties encourages us to use hydrogen as a cooling media. And what effect it has on the generator itself? Now, since we are using hydrogen, it will be properly sealed and no impurity can invade the hydrogen. So as no impurity can invade the generator itself, the internal of the generator will be clean throughout. So generator internals are always clean. So it will not affect our flux distortion, it will not affect our temperature of various parts of the winding due to any impurity. Then due to the density of hydrogen is very less than that compared. So the windage loss will be less. Again, as the density is less, the noise of the air circulating when the rotor is rotating will be less. So hydrogen cooled generator are less noisy than the air cooled generator. Then we have better heat transfer. Why better heat transfer? Because hydrogen, same amount of hydrogen carry 14 times more heat than that of air, and it can more effectively transmit heat from a heated surface to a colder surface. So we have better heat transfer. So the internal or the rotor of the generator will be cooled more effectively than that in case caused with air. So if it is cooled effectively, then it can maximize the generator output. This means whatever be the generator output, suppose we have a 100 megawatt generator that is air cooled, and if we cool that generator by hydrogen by establishing proper cooling and sealing system of hydrogen, in that case we can enhance the output of the generator because the current is directly related to heating capacity. Voltage will remain same, and if we can increase the current, the output of the generator may be increased from 100 megawatts to 120 megawatts suppose. So it maximizes generator output. Again, if we use air, it can have corrosive effect, but hydrogen does not permit this corrosion, and also hydrogen increases the breakdown voltage. So due to this, hydrogen, using hydrogen as a cooling medium, we enhance our generator performance. Now, we have a limitation with hydrogen because if the purity of hydrogen is not properly maintained, then it can form explosive mixture with air. If you have read a news, it's somewhere in UP in NTPC plant, not in NTPC, it was UPPCL plant, Anpara A. Recently there was an explosion in generator, I think before just lockdown. Why? Because the hydrogen purity was not maintained and some maintenance work was going on, and they had allowed hydrogen to fill the generator, and that pipeline had exploded. The reason was because hydrogen forms explosive mixture with air or impurity. So we have to maintain high purity of the hydrogen. And to maintain that purity, what we do is that we online check the availability, or we check if the purity of hydrogen is above 99 or not, or above 95 or not as per our maintenance specification. And if there is any loss in this hydrogen, then we also monitor the pressure of the hydrogen so that we replace the hydrogen. Online replacement of hydrogen. It means there is a online monitoring system of purity and pressure of hydrogen. You can go through this, and this video is uploaded, or the audio recording is also. So now, after hydrogen cooling system, we see what stator is cooled. Generally, we cool the stator at a higher temperature capacity by water, and water is a demineralized water issue that flows into the tube. There is no direct contact between the winding and the So in case of hydrogen cooling, we cool the rotor, and in case this stator part is cooled by water, demineralized water will flow into the tube, and there will be no direct contact between the water and the winding because this will short circuit the winding itself. Now this is the winding which we are seeing. If we go in detail, we have this Teflon tape that is inlet water, inlet header and outlet header. These Teflon tubes are used in which demineralized water will be flowing. Now in this case, hydrogen, this water, you have to monitor water system always. This is the same winding and that is the same winding, just I have to put the inlet portion of water. See, electrical connection is made here, while hydraulic connection is this. There is no direct connection between the water connection and the hydraulic connection. That is why we call that stator is indirectly cooled, and indirectly cooled by water. See, this is a hollow strand. Here is the nozzle through which the water will be going inside. Now this is the system for stator cooling water. You take a schematic, we have pumps that will be pumping water, and this will be taking the water from an generally no water is wasted in this. So the water that is being used, that will pass through the cooler and the strainer, so that the temperature of the water is maintained to a desired level and strainer that no impurity flows into it. And then we have a resistance column here, so that the resistance of water is maintained. Because if we cannot maintain the resistance, proper resistance, then it may short circuit the stator winding. And then after the header is there, then we have a return header, that if any gas has been placed in that, it will be removed from that gas retaining chamber, and then it will again be fed to this inlet chamber of this pump itself. Again in this process we have deoxygenating chamber also. So this closed loop system is used to cool the stator. So hydrogen is used to cool the rotor and stator is cooled by this water system in high capacity generator. If the capacity or size of the generator is less, this system may not exist. All the parts I have tried to enlist here what they represent. You go through it will be clear. Now, once we are using hydrogen and hydrogen can form explosive mixture with air, so what we need is we have to protect any ingress of foreign material into the generator so that the property of hydrogen can be maintained. For that, we use the generator sealing system. Here, what we do, the turbine is having lubrication system and same oil we use for sealing the generator. So, this end part, what we do, when the rotor is rotating and supported, here we provide the oil sealing. You can go through it whatever are the uses. I am just telling you the oil sealing system. So we have a AC pump that will pump oil when pressure of oil decreases or when main oil pump is not able to provide sufficient oil pressure for sealing. So when the turbine is rotating at its full speed, MOP will function to provide this oil into this header. In case that fails, then what will happen? AC pump will start and this will go through the filter and the cooling service water system, so that the temperature of this header is maintained and this will go to seal the generator rotor. Once the sealing is done, then the same oil will be passed near to the hydrogen retaining chamber. Now, by the density differential, hydrogen, if some hydrogen is mixed with this, then hydrogen will go up and oil will come down. Now, we are sealing this, so the oil pressure will be more than that of hydrogen, always. Some oil may ingress into this inside. Now, then after this retaining chamber, we take this oil to the hydrogen trap. This means any hydrogen that may be left, we are releasing into the atmosphere, and then oil by gravity itself goes to the turbine main oil tank. This is the same main oil tank that has auxiliary oil pump, that has emergency oil pump, or that has the judging oil pump. Same oil tank here now. In case this MOP fails and then the AC pump also fails, then even the sealing system should not fail. Then that condition we have DC pump. Again, this is the emergency pump, so it will not follow the normal path of filter and cooler. It will directly provide this sealing system. So these pumps are used. There will be various control systems, that is oil pressure will be regulated, oil temperature will be regulated. There are two service coolers, so that we can bypass one if there are one cooler here. So there is a filter. So filter is there, then there will be in any filter which we are using, we must have a pressure switch, differential pressure to measure the differential pressure. If the filter is low, then we have to clean the filter. So this is all about generator cooling and sealing system. If you have any doubt, along with this live video, we will be uploading the audio recording video in this. So you can go through this. Now if you have doubt, you type in, or I will be just going to the doubt that you are having in turbine system, so that is clear. I will just draw the line diagram of what sequence of operation we follow, so that our turbine can be taken to service. Next day I will try to cover even some parts of boiler along with my generator part, that is the synchronization and capability curve tomorrow, which I will be taking along with that some boiler part. Today I will be taking up some turbine part also. So if you have any doubt, you can just type in or I'll go to turbine part. Alright. We have one question here. What type of cooling is provided in generator in power plant? See, it depends on the capacity of the generator. Suppose it is a captive power generator. This captive power, we can classify generator as per its operation used as utility generator and captive generator. Captive generator is a generator that uses 60% of its power for its own consumption. Suppose we have an aluminium plant and it is a captive power plant. So that will be using majority of power for itself. That will be a captive power plant. And the size of that plant will be around 100 megawatt, 150 megawatt, or 150 megawatt. So these plants may not go for hydrogen cooling and water stator cooling system. So they will go for generally air cooled system. This is because the size is less. But if you go for NTPC, that is a utility based power plant. That is main purpose of the plant is only to generate power. So it will generate power for others. So it will be using that power. So the size may be from 250 megawatt, 500 megawatt to 600 megawatt or even 800 supercritical technology. So in these cases those are above 500 megawatt, there will be hydrogen cooled rotors and water cooled stator. And 250 megawatt can have water cooled, they can have a mix of air and water cooled or a mix of hydrogen. Yes. So these are used. Can you explain again how the sealing is done? Sealing, we are sealing the generator rotor because we are cooling the rotor by hydrogen. And rotor, this hydrogen can form explosive mixture if the purity of hydrogen is not maintained. So in order to maintain that purity, we use oil sealing system. The oil that are used for turbine lubrication system, same oil is used for sealing the generator. And for that, we have seal oil system, other pumps are there. Send us today's study material and the password. I told you after the class it will be uploaded. Everything will be provided to you. You get that. How is the winding temperature control in a closed cycle air cooler? Now, I suppose if you are having air cooler in case of generator, I will explain according to generator itself. How is the air temperature? Now, when air is going into the generator, we have outside, we are cooling the air using water. This means we have a other cooler. The air that is going inside the generator will be initially cooled using indirect cooling method. This means inside tubes will be having water and air will go through this tube so that it is cooled initially. And generator tripping is also given as per the cooling temperature of the air. This inlet and outlet temperature of the air. I suppose I have answered this question. This lecture will be uploaded. I told you this online class will be uploaded, and this PPT that I have shared, this will with voice over video, that will also be uploaded. I have explained in that also every part in detail. That will be uploaded and that will be uploaded in the first half. After this, my lecture finishes. Now, I suppose you are asking this again in case of generator cooler or provide reference. What is the damper winding provided? Provide reference which damper winding you want. What is the temperature max of the winding? Now, again, temperature depends on the type of insulation used. It can be A class, it can be B class, it can be F class. Generally, in generators use F class insulation. F class insulation generator has a winding temperature maximum allowable limit up to 150 degrees. So, but we cannot go maximum allowable temperature. Generator is fixed at around 110 degrees centigrade. We have alarm at 100 degree and at tripping at 110 degree. How is electricity generated in a generator? I suppose it is already discussed. How is electricity generated? Faraday law of electromagnetic induction. But still, if you have doubt, I will discuss this again tomorrow when I will be going to the generator synchronization. I will touch this basics of how is electricity generated. I think this is covered. I don't know why you are asking this question, but I will deal with this briefly when I will be studying about generator synchronization tomorrow. I will clear this out tomorrow. Still, you are not read. Why is the damper winding provided? Reference which damper winding are you talking about? Any other question you can type in. Any other question of turbine operation also you can type in. If you need break for turbine, I'll then break for that 5 minutes, then join again. If you need time to put on query of turbine, I can do that even. But today, at least clear the doubt of turbine generator also. If I deal tomorrow even. In case I missed any question here, you can type in again. And is my audio audible to you today? Or today also you have issue? What types of seals are used in generator? Generally, see, if you go to the sealing system, the one name is a labyrinth seal. Why labyrinth seal is used? We are using that for gland sealing. That is mechanical part of the sealing. Labyrinth seal can be used when we are using. And here what I have discussed is that seal is a metallic ring that will be spring supported. If you go to the audio say, and then we are putting in water, we are putting in oil in order to seal the hydrogen from any preventing ingress of any foreign material in order to keep the purity of hydrogen intact. So that type of seal we are using. This seal is actually a brass ring with an inner diameter. If you go through this, you'll get that. A labyrinth seal, what I told was using sealing of turbine. If you go to study turbine, they will be having labyrinth seal. What is the slip ring and brushing? Today also I think Guriji has covered this, but still, what is the purpose of slip ring? Now, whenever you have to inject any power into a system, rotating system from a stationary part, when you do that, you need brushes. So brushes are used either to provide power inside a rotating part from a stationary one, or to take out power from a rotating to a stationary one. So brush will be required. And slip rings, in order to, because in excitation system when you provide DC power, polarity is constant, but the generator is rotating. So you need the slip ring to provide that. Sometimes you see when you are taking output also from generator, R by B phase, you need that slip rings. It is in reference to that. Today's lecture, it might be covered with Ampuri has taken. But still, if you will have doubt, I will clear this doubt again. But I think it is clear in that if you go through the video that it will be uploaded. If you have any doubt in the turbine operation, you can type in. I am telling you, I'll clear that doubt itself. Boiler I will take up tomorrow. But today, turbine, if you need, I'll clear that doubt. Back pressure in case of turbine. Okay, one question is there. Let everyone get clear. So that they can switch from electrical to turbine portion. I'll take up this question. A back pressure refers to the pressure that exists in the last stage of turbine and in the condenser. This is related to that. If the vacuum of the condenser is not properly maintained, what will happen? The steam in the last stage of turbine will not flow to the condenser. And if it will not flow to the condenser, then the condensation of the steam will take place in the last stage blades of the turbine, which is not desirable. So, this pressure that is building up in the condenser that prevents the entry of the last stage steam to the condenser, we call it the back pressure of the turbine. Okay, second question has come up. I'll take a 5 minute break. Okay, you all think of this turbine question, we'll disconnect, take a 5 minute break, and join again. This question I'll take up, you copy this question and type in again. I'll take up this question after just 5 minute break, and others also think the question which you will be dealing. Turbine question, I'll take, if you will not be having question, I'll just go by operation of turbine, what step will take, so that all other questions are clear to you. I'll be just taking 5 minutes break. And then I'll take up this question up.